This lesson, we will learn construction of bridges, and the objective is to explain the methods and technology in bridge construction. So for bridge construction, most of the figure and table I use from Brno 2013. And in terms of the type of bridge, as you can see, bridge can be as simple as the one shown here, and happy a lot discover bridge in where I come from, Vietnam, and of course many areas in Asia, and it still exists nowadays in the rural areas. And then go back to Florida in our areas. I'm not sure you with this finger you recognize what bridge it is. Basically, this is a bridge built 6 years ago for the terminal access road to the Southwest Florida International Airport to I-75, and that I-75 airport access project. And this one nowadays is already completed, but that you can see to build such kind of bridge under the traffic, I-75, it really a challenge. And during the construction of this one, there are many closure for the work zone safety. And as you can see one example here for February 3, 3rd to 7 at 2014. And you can see for the crew install the bridge beam over I-75, FDOT, Florida Department of Transportation, have to close the I-75 for your construction work. So with that, consider the safety, the construction method, all of that will play a key role in bridge construction. And with that one, I see one example here why it's so important. If you recall, something happened in the east coast of Florida that we have here. And so with that video, you already know what that project I'm talking about. The FIU Florida International University bridge collapse, pedestrian bridge collapse in March 15, 2018. So basically 2.5 years ago. And this year bridge is about, and that happened. The problem can be from the designer, it can be from the construction, and as you can see, it always debatable. And there is a consequence that both engineer and constructor involved in this project have to pay price. For example, the engineer may be suspended from participating federal funded project for certain years. If you Google it, you have to see that information, and that disaster. And it this accident, it caused 6 fatals, 1 workers, and then pedestrians, and then the commuter with the under the car, and it also create 6 other non-fatal injuries for this accident alone. So the safety play a key role in determining the construction method for the bridge. The bridge that built with the project here, FIU pedestrian bridge, we call it ABC, accelerated bridge construction. We will get on that in the next videos when we talk about the construction method of building the bridge. So with that one, let's go to the common bridge design so that you can see what are the typical type of bridge and how that design look. Of course, by no means we with a few minutes you can be able to design a bridge, but here give you an overview what are the type of bridge and how that work here. The first one, as you can see, popular, that is continuous or simple span bridge. It depends on what is the span between the two valley or the river, etc. So it can be continuous or simple span. So this one, so continuous to span it from the abutment from this side to the other side, and of course there is support, in this case pi caps, two pi caps underneath. If you have a joint here and they are joint, so separate, then it become a simple span. If the beam is continuous from this to the other side, then it continuous span. So that typically beam bridge, girder bridge that you see. The and that you can see the rigid frame. It sometimes it have it connect between the two abutment, and as you can see here, the ridges, because the frame here it become a steep connection from the deck, and the incline like in here that become a ridges member. So that is ridges frame. This one you did in engineering mechanics, the through truss. It can be make mostly from steel. It can be concrete, but mostly steel. The concrete for the truss, and you can see that it FIU a pedestrian bridge that I just showed you the accident a few minutes earlier. So this one is through truss, so that is another type of bridge that you have. And then we also have the top deck arc, something we need arc involved, and with the especially many areas that the city built 100 200 years ago, a lot of arc bridge that you can see here. So the deck and then the arcs to support the deck in there. And of course we go to a more modern bridge, we have a suspension bridge, and that can, when we need span higher, longer, so that the ship, the boat can go through. And with that one, the tower we call it pylon, and then we have anchorage to the two sides of the river or two sides of the abutment, and we have an anchorage. And then we have a main cable that go through from the anchor to the top of the pylon, and then to the other top of pylon, and go to the other side of the anchors. And the cable go from the main cable to the deck, we call it hangers. So that what we have for the suspension. And then the cable stay bridge that you have. So before, to build the bridge that need a long span, we have suspension bridge. But recently cable stay become popular, and it can have a wider spacing or span between the two pylons, so that we can ensure the navigational system can go through with the underneath of the cable stay bridge. And again, it pylon for the tower, and in this one, instead of main cable for the suspension bridge and then the hangers, we have the cable go directly from the track to the pylon, anchors to the pylon. So that's the difference between the suspension and cable stay. In terms of cross-sectional views, you just want to go over a few terminology and concept. So example here, if you have pile and then pi cap, so pi deep foundation go to the bedrock of the soil, and then we have pi cap and we build the pier and another pier cap, and then you have a girder, and then the deck and the traffic go through on top of that. In terms of the deck, it can be steel plate, as you can see here, or it can be precast concrete. So it precast girder, fabricated offsite, transport to the site in stone, and then you can place concrete and rebar on here for the deck. And then we also steel box composite, so it's that composite steel, concrete, etc. And this one, and you can see it also have other cross section that you can see for different type of bridge in there. And for the cable stay and the sail anchorage, we also have the cross section. So you see hangers, so this is for suspension bridge, This here for the cable stay, and also have always needs, as you can see, normally they need a pier and then pie cap, and it may have pier or the pylon cap or pier caps, and then we have a pylon and then the cable. Now let's take a look of the suspension bridge that you can see here. So like I say, the anchor is to the both sides of the bridge, and this is the main cable, and then the hangers and the deck. The traffic go through here, so I think most of you may already go through a suspension bridge. One of the most popular bridge in the world for suspension bridge is the Golden Gate Bridge in the Bay Area, San Francisco Bay Area, California. That I have chance to drive through that bridge several times, if not many. So you have that is suspension bridge, and normally, as you can see, anchored to the shore or the rock on both sides. The other bridge that I also have a chance to explore, that we call it self-anchor suspension bridge. So what does that mean, self-anchor? Conventional, like I say, it anchored to the both sides of the bridge here, but this self-anchor is anchor in the structure itself, and the most largest self-anchor suspension bridge are the new bridge built in the Bay Area as well, that we call San Francisco Oakland Bay Area Bridge, that built and completed a few years ago. And this is a picture I took, and this is the self-anchor. Instead of the anchorage go through the soil or the rock on both sides of the bridge like a conventional suspension bridge, this one is basically the anchor that took here, this area. So the cable will go through this and go up. So it because that way it's anchor, and this is a big mighty anchor. So if I stand here, it's not up to here yet, not up to here. So it's really big anchor. The last one that we're talking about is cable stay bridge, and as you can see here, instead of the their main cable and then the hangers go from the main cable to the deck, this one the cable go from the deck to the pylon, as you can see there. And there several version fan design of continuous cable. So as you can see in one area, so it's continuous. This one is half design with parallel cable, so the cable is parallel in there. And one of the cable stay bridge in our areas, not in locally, but you see the road when we drive to the Sand Pit in Tampa, go through I-75, then you can have that go through that cable stay bridge. And the last one we consider, because the bridge is exposed to the weather, it especially in Florida, the temperature change between the day and the afternoon. It can be 20-30 degrees, and that we need to have expansion joint, and that we need to consider. Of course, you want this the expansion enough to take care of the extraction and contraction when the temperature increase or decrease, but you don't want that if the gap is too much, that will be not only feel unpleasant when you drive, but you can have more noise when you drive, etc. So determine the gap between the expansion joint, between the girder and the bearing, between the deck and the abutment is very important in the bridge design. And the next video we will apply that concept to determine to check whether the expansion joint design meet with the construction and extraction due to temperature changes in the problem one.